Welcome dear student to our YouTube channel. Today we will start the solution chapter. In this lecture I will complete the major portions of solution chapter, not from the base, starting from the basic level from where I will start. So let make heading solution. Make heading solution. So solution is that type of substance which is produced by the combination of solute and solvent. Solute and solvent combination results in the formation of solution. So it may be classified into different categories. We will study these categories in coming lectures. So I will just give you an example of solution. So let's take the example of table salt or common salt, which is NaCl, and if you add NaCl into some volume of water, then or you can take it as I am just writing water. So it will produce salt water, and the salt water is solution, or is one type of solution. Is the solution. So remember that solution is always produced from the combination of solute and solvent, and solute is that part of solute is that part of solution which is present in small amount in the solution. So any substance which is present in solution in small amount, that substance is termed as solute. So in this case, in salt water, NaCl is present in lower amount or small amount, that's why it will be termed as a solute, but the volume of water is more in comparison to the amount of the salt, that's why it is termed as solvent. And the two substance, that is solute and solvent combination, produces the solution. And upon heating a solutions produces vapors. What happens in daily life? If you heat water at its boiling point, that means at 100 degrees centigrade, then what happens? It starts producing vapor, and the vapors produces pressure, and that pressure will be termed as vapor pressure. In this lecture, we will learn in detail about the vapor pressure and some laws which uses the vapor pressure concept. That means in this lecture our aim is to study upon the vapor pressure. After that we will go for the laws which uses the vapor pressure. Let's start. The vapor pressure, make heading vapor pressure. Vapor pressure. So to understand vapor pressure, we will take the example of a diagram. So I am just drawing here a diagram. It is a container, and this container contains a volatile substance. Consider these are the volatile substance I have mentioned in this portion. What is volatile substance? So if it is a volatile substance, then the surface molecule, consider these are the surface molecules, these are the surface molecules present on the surface of the solution or liquid. It may be a solution we can take or it may be a liquid. In this case, this is a surface molecule, and if I will place here a lid helps us to close the container from its opening side. So just I am closing the open part of the vessel, and it is the, you can tell it as the lid which closes the opening part of the container, and mark that if it is a volatile substance, I am writing here, it is volatile substance or volatile liquid. You can take it as a volatile substance or volatile liquid. What you can tell? Volatile substance or volatile liquid. So, any volatile substance, we know at room temperature it produces vapors. That means it will produce vapors, and consider these are the vapors. These are the vapors produced from the volatile liquid at room temperature. The vapors cannot be released to outside as the container's opening part has been covered by the lid. That's why the vapors will present at the top part of the liquid level. And what is vapor pressure? So when the vapors are present, they will exert a pressure on the upper surface, or on the surface, you can tell, on the surface of the vapors will start producing pressure on the surface of liquid upon which or over which they are present, and the pressure exerted by the pressure, these are the vapors or gas, you can tell these are the vapors or gas. These are the vapors or gas produced from the volatile liquid, and the pressure or the, you can tell it as not the pressure directly, it is the partial pressure because all the molecules are different. So the partial pressure exerted by the vapors or gas on the surface of or on the upper surface of liquid will be termed as vapor pressure, and the vapor pressure is always studied at a constant temperature and pressure and at equilibrium condition. Equilibrium means the rate of forward reaction. The rate of forward reaction should be equal to the rate of backward reaction, because this reaction is going backward, and this reaction means vaporization along with pressure exertion goes in opposite direction, and the reaction should be in equilibrium condition to study the vapor pressure. So we will again write the definition. After that we will come for the concept again. So write the definition. Pressure exerted by, which pressure? Partial pressure. Partial pressures. Partial pressure exerted by vapors or you can say it as vapors or gas on the surface of you can tell it as a liquid, or what I have told, the liquid may present in solution. So the partial pressure, mark the main points, partial pressures exerted by the vapors or gas, these are the vapors or gas which exert the pressure on the surface of liquid, or solution, on the surface of liquid or solution. at equilibrium. I have also told what is equilibrium. Equilibrium. And equilibrium is called as vapor pressure, is termed as vapor pressure. So, again repeat the definition. Partial pressures exerted by the vapors on the surface of liquid or solution at equilibrium is called as vapor pressure, and the vapor pressure is always studied at constant temperature and pressure condition. Always remember the condition during study